Hi everyone, I'm Nayanda Vikram Singha, a final year student at Informatic Institute of Technology. Today I'm going to talk about the BeSense app, a virtual assistant to identify the content of the printed materials for the people with sight aids. Let's go with the content. Problem background. The global population includes a significant number of individuals with disabilities, particularly those related to vision, psychologically, or learning. Visually impaired individuals face challenges in accessing and understanding printed materials, especially complex elements like tables and long paragraphs and graphs. While Braille offers a solution for basic text, it falls short when it comes to complex visual content such as tables, graphs, and lengthy paragraphs. This reliance on external assistance hinders independence and accessibility for visually impaired individuals, impacting their ability to engage with educational, professional, and day-to-day materials. Assistive technologies aim to address these challenges, offering tools and devices specially designed to cater to the needs of individuals with disabilities. However, existing solutions often prove to be slow and not easy to use. Despite advancement in technology, there remains a significant gap in providing effective tools for converting complex visual content into accessible formats for visually impaired individuals. This limitation further exacerbates the barriers to independent learning and engagement with printed materials. Machine learning and deep learning technologies offer a promising avenue for addressing these challenges by enabling computers to analyze and interpret visual content. However, practical solutions leveraging these technologies are still in their nascent stages, with few options available to meet the diverse needs of visually impaired individuals. Proposed solution. The development of a digital assistant presents a significant solution for individuals with print disabilities, enabling them to independently interpret printed materials. While sighted individuals can rely on their eyesight, those with print disabilities require assistance to access and understand printed content. This digital assistant addresses these challenges by providing audio guidance and a user-friendly interface accessible to individuals with visual impairments. To better visualize of the proposed solution, a concept map is created as a visual representation. It outlines the various components involved. Existing approaches for the feature extraction, image segmentation, deep learning for classification, and etc., and evaluation on the approach on functional, non-functional, quantitative, and qualitative data, deep learning for domains, limitations of the approach, and problem-solving approach with ML and image processing, including ensemble, ANN, and CNN modules. The application utilizes a camera to capture printed materials, automatically identifying and distinguish various elements such as text, tables, and graphs. Through advanced algorithms, the assistant accurately interprets the content, providing precise information via voice assistance. Unlike existing image description apps, the assistant leverages surrounding text for enhanced accuracy. Key functionalities include reading table data, identify the graphs, and providing guidance with those materials. The user is guided through voice commands, ensuring optimal positioning of the camera for accurate capture. Overall, this assistive application aims to empower individuals with visual disabilities, enabling them to participate more independently in society and gain a better understanding of their surroundings. Research gap. Existing mobile tools for assistance to individuals with print disabilities often lack functionalities for comprehensive table and chart detection within printed documents. While some solutions are available, they typically do not offer robust features for interpreting tables and charts, leaving a gap in accessibility for vision impaired users. These tools often prioritize text recognition, overlooking an importance of graphical data interpretation. Moreover, publicly available apps often lack the capability to interpret all document content at once. Especially tables and charts highlights the need for more comprehensive solutions in this regard. This study aims to address this gap by providing user-friendly tools capable of accurately interpreting and summarizing tables and charts in printed documents, thereby enhancing accessibility for individuals with print disabilities and facilitating a more inclusive approach to information access. Let's move to the demo and the code of the application. The demo of the application, the video, will show how the capturing images and uploading images will give the results via voice output from the application.
Click centered live document detection. Click bottom to capture the photo or middle to select from gallery. Click center to get audio details. Columns of the detected image are HT, I, Club, WT, IO complete, FG%, 534, born, P2. Live document detection. Click bottom to capture the photo or middle to select from gallery. Click center to get audio details. Columns of the detected image are year, club, G, FG%, rev, ast, STL, block, PTS, ABG. Total number of rows are 7. Total number of columns are 10. Maximum values of the columns are year total.
The user will capture the document with the aid of assistance from the mobile application, and the captured document will be sent to the processing backend to extract the summarize the data from the document image. Then the summarized data will be sent back to the mobile device to output the data as audio using a text-to-speech engine. To assist every possible user, the mobile application is developed with assisted document focusing and automated document capturing. These assistive functionalities are developed using OpenCV native libraries for edge detection and using a separate TensorFlow Lite in-device model for object detection to identify documents. The UI of the application is designed with bigger buttons suited for vision impaired users, and users will get audio assistance on where to touch or do a certain action in order to perform certain tasks. Furthermore, the UI is designed with colorblind use in mind. Let's discuss the methodology for each major components. Assistive document capturing, document segmentation and content classification, chart interpretation, table comprehension. Let's move with the assistive document capturing. The front-end module developed with Flutter incorporates real-time image processing to identify documents via the mobile camera. Due to network latency concerns, lightweight solutions were preferred, leading to the use of TensorFlow Lite for object detection. However, utilizing complex models like YOLO or SSD remains challenging for most mobile processors. Instead, document detection relies on edge detection methods leveraging OpenCV native libraries for Android. With Flutter's capability to interact with native APIs such as camera APIs, processing occurs swiftly, encompassing image enhancement, contour detection, and corner identification in real time. For document segmentation, the implementation utilizes the layout parser library, which employ Detectron 2, a state-of-the-art object detection algorithm for document image analysis. Layout parser features pre-trained deep learning module tailored for different document layout analysis tasks. Ensemble learning with multiple pre-trained layout parser models trained on datasets such as PubLayNet, and it employs for layout analysis. While the PubLayNet trained module specializes in accurately identifying general document areas like text, titles, and tables. Chart interpretation. A convolutional neural network, CNN, based on the VGG16 architecture classifies the table input charts utilizing SGD optimizer with a 0.001 learning rate. Images are pre-processed to a fixed size of 224 into 3 before network input. Chart interpretation models build upon the craft model, identifying axes for bar and line charts by detecting longest horizontal and vertical lines. Connected components analysis is used for bar charts to fit rectangles for each bar and calculate values. For pie charts, gradient analysis identifies boundaries and volume calculation determines slice values. Tesseract OCR engine identifies the labels and legend colors corresponded to slices. Plain English sentences are generated using a template-based sentence generation method after data extraction. Table comprehension. This tool analyzes printed table to identify the arrangement of XY axis and table contents. Storing the recognized data in a CSV file and summarizing the table's creation data. OpenCV libraries are primarily used to split tables when evaluationary techniques coordinate validate table, while evaluationary techniques convert digital images to binary and apply filters for precise table identification. PyTesseract is employed for text extraction and XY coordinates validate table threshold values. sklearn clustering processes the data and the result is summarized and delivered in the user as an audio file. This research contributes significantly to both technological and domain aspects by addressing existing gaps in the field. Technologically, it introduces an innovative method for analyzing tables and charts in printed documents, utilizing feature extraction and OCR methods with the text classification model. This approach enhances efficiency and the accuracy compared to existing methods, as demonstrated through comparative assessments. Domain-wise, the research advances technology by accurately detecting and extracting data from tables, improving automation in handling tabular data. It also enhances chart classification through the development of neural network, enabling precise identification and classification. While this study addresses significant research gap, it also has inherent limitations that can be addressed in future research endeavors. The primary constraint lies in the quality of smartphone cameras, which heavily influences the study outcomes and may lead to variations in results across different mobile devices. Future involvements aim to overcome these limitations by supporting more complex chart types like stacked bar charts, scatter plots, and box plots. Additionally, efforts are directed towards refining the edge detection component to avoid mistakenly detecting other objects with similar shapes as documents, possibly through the inclusion of an object detection model in the mobile application. Further enhancements involve detection complex tables, increasing accuracy level, enhance this to identify mathematical equations and content of the images, and extending support for languages beyond English. Overall, future research will focus on overcoming these limitations to enhance the effectiveness and the applicability of the developed application.